Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera bagi kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan.
Good morning, may the peace be upon you all.
Yang kami hormati, Direktur Politeknik Negeri Malang, Bapak Supriyatna Adi Suwigno, ST, MT.
The Honorable
Pembantu Direktur 1, Ibu Dr. DRA Kurnia Ekasari, AKMM.
The First Vice Director of State Polytechnic of Malang, Honorable Ibu Dr. Kurnia Ekasari.
Pak Jaswadi, SE AKMSI DBA.
The Second Vice Director of State Polytechnic of Malang, Honorable Bapak Jaswadi.
Yang kami hormati, Pembantu Direktur 3, Bapak Dr. Eng Anggit Murdani, ST, MN.
The Third Vice
di Politeknik dan Koordinator PSDKU yang kami hormati.
The respectable all the head of the departments and PSDKU coordinators.
Yang kami hormati, Ketua Panitia IEIT, ATASEC, dan SNGBR 2022, Dr. Eng Rosa Andri Asmara, ST, MT.
The Chairman of the Committee of IEIT, ATASEC, and SNGBR 2022, Honorable Dr. Engineer Rosa Adri Asmara.
Yang kami hormati, para narasumber dan moderator, tamu undangan, seluruh pemateri, panitia dan peserta IEIT, ATASEC, dan SNGBR 2022.
The Honorable keynote speakers, moderators, invited guests, and all the distinguished presenters and participants of IEIT, ATASEC, and SNGBR 2022.
Puji syukur kita panjatkan kehadirat Tuhan Yang Maha Esa yang selalu melimpahkan rahmat dan karunia-Nya sehingga kita bisa berkumpul di dalam acara IEIT, ATASEC, and SNGBR 2022.
And we would like to thank everyone for attending this remarkable event.
Sebelum kita melanjutkan acara, izinkan kami memperkenalkan diri terlebih dahulu.
And saya Chan Polamol.
Dan saya Farida Ulfa, selaku pembawa acara pada pagi hari ini.
Our today's agendas are as follows.
Dan berikut ini, izinkan kami untuk menyampaikan susunan acara pada pagi hari ini. Pembukaan,
the opening,
menyanyikan lagu Indonesia Raya,
the national anthems of Republic of Indonesia, Indonesia Raya.
Pemutaran video profil Politeknik Negeri Malang,
playing profile video of State Polytechnic of Malang.
Sambutan dan pembukaan acara oleh Direktur Politeknik Negeri Malang.
Welcoming speech and event opening by the Director of State Polytechnic of Malang.
Sambutan dan laporan oleh Ketua Panitia IEIT, ATASEC, dan SNGBR 2022.
And welcoming speech and report by the Chairman of the Committee of Joint IEIT, ATASEC, and SNGBR 2022.
Selanjutnya adalah pemutaran video Kota Malang.
And then playing profile video of Malang City.
Presentasi oleh pembicara utama.
And presentation by keynote speakers.
Dan yang terakhir adalah penutup.
And the closing.
Mengingatkan kembali, dimohon para pemakalah untuk menggantikan ID Zoom Bapak Ibu menjadi nama conference, garis bawah, Parallel session atau breakout room, garis bawah, nama lengkap. Misalnya, SNGBR garis bawah 4, garis bawah Chan Paul Amol. ATASEC garis bawah 2, garis bawah Chan Paul Amol.
For parallel session, each room consists of 10 to 15 presenters. Each presenter has 10 minutes to present their paper and 5 minutes for questions and answers. Please remember to change your Zoom ID using the following format. The conference name _ parallel session room _ your full name. For example, SNGBR _ 4 _ Chan Paul Amol or ATASEC _ 2 _ Chan Paul Amol.
Presensi akan dibagikan di kolom chat untuk sesi plenary dan paralel. Bapak Ibu, we would like to remind you that the attendance list for the plenary and parallel session will be shared in the chat box. Kindly fill them. Thank you. Memasuki acara yang pertama, yaitu pembukaan. Sebelum kita memulai acara pada hari ini, marilah kita sama-sama membaca basmalah. Bismillahirrahmanirrahim.
Distinguished guests, ladies and gentlemen, let's open this event by saying Bismillahirrahmanirrahim.
Selanjutnya, menyanyikan lagu Indonesia Raya. Selanjutnya, mari kita saksikan video profil Politeknik Negeri Malang.
State Polytechnic of Malang, or Polinema, is a state vocational higher education institution located in Malang City, East Java. Polinema was established in 1982 with the name Education Program of Engineering Diploma, Universitas Brawijaya. Polinema's vision is to be a leading vocational higher education institution in the global competition. Polinema has 7 departments with various Diploma 3, Diploma 4, and Applied Master's program. Polynema also offers international classes and double degree programs in collaboration with its international partners. With professional education that uses human resources, Polynema equips students with hard skills and soft skills required by the industry. The learning process at Polynema is oriented to developing students' hard skills and soft skills. The development of students' hard skills is conducted through the concept of learning by doing. Presenting 40% theoretical lectures and 60% practice. The learning process is also aimed at developing student characters such as honesty, leadership, discipline, teamwork, and the ability to work smart. Polynema provides vibrant and welcoming environment for teaching and learning, research, and community service activities. Collaborating with the industries, Polynema holds collaboration-based programs. Polynema has 7 departments and 30 study programs at main campus. Department of Electrical Engineering, Department of Mechanical Engineering, Department of Civil Engineering, Department of Accounting, Department of Business Administration, Department of Chemical Engineering, and Department of Information Technology. Polynema also has applied master's program. Polynema has PSTKU campuses. PSTKU Kediri City with 6 study programs. PSTKU Lumajang Regency has 4 study programs. PSTKU Pamekasan Regency offers 3 study programs. Polynema students are well recognized for their achievements and innovations at both national and international levels. Polynema, creating global professionals.
Hadirin sekalian, Acara selanjutnya yaitu sambutan sekaligus pembukaan acara oleh Direktur Politeknik Negeri Malang. Kepada Bapak Supriyatna Adi Suwiknyo, STMT, disilahkan.
Distinguished guests, ladies and gentlemen, our next agenda would be the welcoming speech and event opening by the Director of State Polytechnic of Malang. Allowed us to welcome Papa Supriyatna.
Terima kasih atas sambutannya.
Thank you, Papa, for the speech.
Selanjutnya adalah laporan oleh Ketua Panitia IEIT, ATASEC, dan SNGBR 2022 kepada Dr. Eng Rosa Andri Asmara, STMT. Disilakan.
Ladies and gentlemen, the next agenda would be a welcoming speech and a report by the chairman of the organizing committee, Dr. Engineer Rosa Adri Asmara. The time is yours.
Focus on the themes, which is science, technology, innovative and academic and vocational research toward product development through industrial and educational cooperations. With keynote speaker from neighboring countries, more than 100 papers were submitted to our seminar from contributors. However, only high qualified articles have been accepted for the oral presentation based on the reviewer results and the recommendations. This year is also the second time for the Malang State Polytechnic to hold an IEIT seminar plan to be published by the IEEE and indexed by Scopus. We want to thank Dr. Engineering Wahyudi Hasbi, who has helped a lot so that we have the opportunity to collaborate with the IEEE Indonesian sections. Hopefully our cooperation can continue in the futures, and with this event, we hope it can be used as a platform for sharing, providing ideas and inspirations, and opening the door for collaboration for researchers. On the same day, joint national seminar on engineering was held at a campus for the 13th time since 2008. There have been many ups and downs during the implementation of this seminar since its inception. I happen to be witness who has often been involved in the committee of this seminar since the first seminars. So we hope that our support for the sustainable futures in vocational education and training does not end here, and that we could learn a thing or two from these occasions. We hope that this year will be our last year of the virtual conference. So we really hopefully that next year, if the conditions are favorable, we will be happy to welcome you to our institutions. And we are sure that your visit to this beautiful city of Malang will give you an unforgettable impressions. This virtual conference is a guarantee of our most safety priorities for all keynote speakers, participants, committee members, and also anybody who is involved. We will try our best to organize this conference to be successful. We also like to report to our principal of the State Polytechnic of Malang, Mr. Supriyatna Adibswikyo, that the ATASEC IEIT and SNGBR 2022 have attracted around 150 researchers, academicians, and practitioners. They are come from different fields of study background in engineering to present and to share their contribution to the science and knowledge in this conference. I would also like to inform you that this event is publicly broadcasted live on YouTube to have a broader audience and strengthening the impact of these events. Finally, on behalf of the ATASEC, IEIT, and SNGBR 2022 committee, I wish our respected keynotes, presenter, and all participants to have fruitful discussion at this conference. Please stay safe and healthy. Thank you very much. Good luck with all of you.
Terima kasih atas sambutannya.
Thank you, Papa, for the speech.
Berikutnya, kita saksikan video profil Kota Malang.
Hi everyone, we are from State Polytechnic of Malang, East Java, Indonesia. I am Salwatul Hifdiyah and my partner is Lia Ujung Tri Utami. And here is the beautiful of Malang culture. Malang, a beautiful and enchanting area which gave birth to a million love from Indonesia. Not only the natural beauty is fertile, but also the earth is so prosperous. Not only a tourist city, but also a tempestuous education paradise. Malang is just not wonderful. Malang is a wonderland. Java Province, Indonesia. Because of its location in the highlands, Malang City has a comfortable and quite cool weather compared to other cities in the East Java region. The second largest city in East Java has various nicknames, such as Paris, Phoenix Java, City of Tourism, City of History, City of Apples, City of Coal, City of Culinary, and many other nicknames. However, the most famous and distinctive nickname of Malang City itself is Student City. The nickname is indeed proven by the many schools and universities that stand in the city. In addition to being the city with the highest student level in East Java, Malang City also has various tourist attractions ranging from historical tourism, such as temples and museums, and religion tourism, to entertainment tourism, such as East Java Park, Batu Night Spectacular, Eco Green Park, Coban Rondo, Coban Palu, which deserves to be visited by both domestic and foreign tourists. Not only that, Malang City is also famous for its diverse and unique culinary tours. Malang is also rich in culture and artistic value attached to its citizens. In the city of Malang, there is also a place that is a means of appreciation of East Javanese culture, namely the East Java Kerja Budaya Park, where various East Javanese culture elements displayed, such as ludruk, ketoprak, wayang kulit, reog, kuda lumping, samba dance. When this acts in new art that's growing rapidly in the Malang City, namely the art of Bantenya. The annual festival, which is an iconic event in Malang, is also often held every year. So the annual city festivals include the Festival Malang Kembali or Malang Festival Comeback, held to commemorate the anniversary of the city of Malang. And the second is the Lantern Carnival, usually held to celebrate the Chinese New Year. And the last one is Malang Flower Carnival, where there will be a fashion show with dress made from the recycled materials. Those are various spectacular cultural riches from Malang, East Java, Indonesia.
Hadirin yang kami hormati, selanjutnya kita memasuki acara inti, yaitu presentasi dari pembicara utama di masing-masing conference. Pada sesi ini, IEIT dan ATASEC akan menghadirkan Mr. Richard Dwight, PhD, dari University of Wollongong, Australia, Profesor Tsukasa Hiroshima dari Hiroshima University, Jepang, dan Ferdian Ronilaya, ST, MSc, PhD dari Politeknik Negeri Malang. Dan sesi ini akan dipandu sepenuhnya oleh Dr. Eng Bani Satria Andoko, Eskom MMSI, selaku moderator dan sekaligus akan menutup acara SNGBR 2022. Sedangkan SNGBR akan menghadirkan Bapak Nugroho Wibisono dan PT Telkom Satelit Indonesia dan Ibu Ratih Indri Hapsari, ST, MT, PhD dari Politeknik Negeri Malang dengan moderator Bapak Sabto Wibowo, ST, MSc, PhD.
Ladies and gentlemen, now we proceed to our main agenda, the presentation of the keynote speakers. For this session, for IEIT and ATASEC would be Richard Dwight, PhD from University of Wollongong, and Professor Tsukasa Hiroshima from Hiroshima University, and Fidan Ronilaya, PhD from State Polytechnic of Malang, with the moderator, Dr. Engineer Bani Satria Handoko, ESCOM, MM, SI. Meanwhile, for SNGBR, there would be Papa Nugroho Wibisono from PT Telkom Satellite Indonesia, and Ibu Rati Hidri Hapsari, PhD from State Polytechnic of Malang, with Papa Sabto Wibowo, PhD, as the moderator. And we'll also close the opening ceremony of SNGBR 2022. Papa Bani and Papa Sabto, the rooms are yours.
Kepada moderator, kami silakan.
...25 to 30 minutes to present their presentation, and the Q&A session will be conducted after all the presenters finish their presentation. And to provide the question, please mention your name and state to which presenter you address your question. And during the presentation, you may also type your question in the chat room. And before the presentation begins, allow me to introduce the presenters. Our first presenter would be Mr. Richard Dwight, PhD. He is honorary professor and director of the Engineering Asset Management Research Group at the University of Wollongong, Australia. The first 19 years of his career was spent in industry in roles from investigation engineer to engineering manager. He moved to academia in 1995 to continue the establishment of the Master's and Research Program in Engineering Asset Management. His research interests and publication records spans engineered asset decision support system, engineering asset management system design, maintenance system simulation and modeling, organizational, specifically in maintenance, performance measurement system, safety analysis and safety system, wheel rail noise, and teaching and learning. For our second presenter is Professor Tsukasa Hirashima. He received his Bachelor of Engineering, Master of Engineering, and PhD from Osaka University, respectively in 1986, 1988, and 1991. He became a professor of the Graduate School of Engineering, Hiroshima University in 2004. And now, he is a professor of the Graduate School of Advanced Science and Engineering, Hiroshima University. Professor Hirashima has contributed to technology-enhanced learning, especially in symbolic artificial intelligence or knowledge engineering in education. He has proposed the open information structure approach as an original framework to design technology-enhanced learning based on knowledge engineering. He has received several awards, example, Distinguished Researchers Award from Asia Pacific Society for Computer in Education in 2009, Field Innovation Award Gold Prize from the Japanese Society for Artificial Intelligence, Award of Ministry of Education, Science Technology in Japan e-Learning Awards in 2021, and Best Overall Paper Award of ICCE 2021. Currently, he also serves as president of the Asia Pacific Society for Computer in Education from 2012 to 2013. He was a visiting researcher at Colorado University, Boulder in 1995, a visiting professor at Indonesia University of Education in 2018, and now he is an adjunct professor of education faculty, Malang State University, and a visiting professor of computer science faculty, University of Indonesia. Our last but definitely not least presenter is Mr. Ferdian Ronilaya, PhD. He is a lecturer in State Polytechnic of Malang. His educational qualifications are as follows. In 2003, he attained his bachelor degree in electrical engineering. In 2010, he attained his master degree in renewable energy. And in 2015, he attained his doctoral degree in computer science and electrical engineering. And without further ado, I would like to welcome our first presenter, and he will deliver a presentation entitled Academic Research in Areas Related to Engineering Assets Management. Ladies and gentlemen.
Well, yes, thank you for this
Please welcome
invitation.
Mr. Richard. Yes, please welcome Mr. Richard Dwight, PhD, and Mr. Richard, the room is yours.
Thanks so much for this opportunity to talk to you about our research at the University of Wollongong in Australia. And my focus is on industry-led research. So all of our work has come from problems identified by industry, which require us to do research in industry as well. So that's been my focus for my whole career, and that's the focus of our team here in Wollongong. Wollongong, it's not too far from you. It's south of Sydney. It's only 83 kilometers south of the city of Sydney in Australia. And certainly many people travel from Wollongong to Sydney on a daily basis for their work. So it's quite close, and there's a nice train ride along the coast to Sydney. Our campuses are also quite nice, as you can see on the right-hand side, almost as nice as yours. We have outreach all around the world, including from Indonesia. We get many students from Indonesia, and we have many interactions as well. And we're looking to increase that, improve that. And in fact, one of my prominent PhDs came from Indonesia as an international student and now works in academia back in Yogyakarta. We have a team here looking at this area called asset management, and I'll explain that in a bit more detail as I work through this talk today. But the sort of areas that we do research is in the asset management system development, statistical data modeling, degradation modeling, both probabilistic and stochastic processes, logistics and supply chain management, system optimization and decision-making models, and application of big data analytics. So I hope you get the sense that we're talking about engineering. We're all engineers, but we're interested in how industry can make better decisions concerning their engineering assets, utilizing data that they may be able to obtain from various sources, including from their own operations. So that's our focus. We do have other areas of research, including in railways area, in particular railway noise, in productivity measurement and management, in production system performance analysis, and in steel processing line design and analysis. A wide range of things, quite diverse, but still always focused on engineering and engineering management issues. The last one there is a recent one looking at robotics or cobots and how they interact with humans, and particularly risk assessment associated with that. Industries we cover, well, all industries, but some we've had more dealings with just partly by chance. The railway industry, the energy pipelines industry, wind power, steel industry, which I came from initially, and heavy manufacturing in general manufacturing, and utilities. Some of the industries we've had direct dealings with and research projects with. We also offer engineering education programs, I guess similar to what you're doing in Milan. The main one we run was the Master of Engineering Asset Management, and that's been on offer since some long time ago. And we did have a program in rolling stock engineering. But our current delivery is the Master of Engineering Management, and that's in asset management. So that's where we come from. The types of research projects that we've delivered over the last few years, I've identified here, and I've underlined the major areas, showing our range of activities that we do. So the first one, looking at risk reduction at level crossings, at crossings between the railway and the road, because of particularly in Australia, we have thousands of level crossings all throughout the countryside, not very frequently used, but still present a danger to the travelling public, the road public, but also to the rail, to the railway lines. So we've been asked by industry to have a look at how we can reduce the risk of a collision at level crossings. That's the current project. Another rail project currently underway is looking at the selection of components for the railway, and I'll talk about that a bit more throughout this talk. Modeling and simulation for risk assessment. That's the thing I mentioned about cobots, collaborative robots. So risk assessment is another area related to asset management and data analysis, and something that's well within our interest. Rail track form selection by life cycle cost models. So again, looking at decision making the best use of available data, and focusing our interest in how people can make better decisions. In this case, using costing models to understand the long run overall cost of selecting a particular item for a railway, in this case, the particular type of track. We've also done work on data capture and analysis we call RAMS data: reliability, availability, maintainability, and supportability data. So that's data that's generated from operating systems that can be used in turn to predict what the performance of a new asset might be, a new design. So try to predict how that's going to perform in service. So again, we're talking about predicting what the future might be, different from just designing the item for a particular range of forces and loadings, but looking at how that performance will work out over time as the item is used, as it's exposed to the environment over time. What's the reliability of that item over time, and how can we then bring that back to an overall cost, a life cycle cost, and use that as a decision tool to determine which is the best choice for a new item. We've done a lot of work with wind energy, and in this case, just highlighting a study tour that we did, in this case in China, looking at their wind energy industry. And we've done work with prediction-based decision support framework for energy pipelines. And again, I'm going to highlight that briefly in the remainder of the talk. Pipeline operation life prediction. So again, looking at, given what we currently know, what's the likely remaining life of a particular asset, which is important for planning, important for security, important for ensuring that systems operate safely and economically. Benchmarking pipe corrosion, looking at life prediction again, predicting service potential for railway bridges, again, a life prediction project with some particular interest. I'll mention that again shortly. And then some of the more technical engineering topics that we've covered over the recent times, including looking at railway noise, the noise generated by railway wheels and rails, the interaction between those two elements. We've done quite some significant amounts of work in that area, and it's also transferable to other machine noise situations. And we've also then looked at productivity improvement, so studying manufacturing systems and looking at what determines their productivity and how we can measure that in a way that promotes improvement from the organization. So promotes improvement, makes it easier to identify where the effort should go to make some improvement. And the last one, a recent project looking more fundamentally at the design of some steel processing machines and what determines their performance and how design changes could improve that performance. So they're the types of projects we've done. The second point I wanted to move on is just to make it clearer what I mean by the asset management system, which is the context really for our research. And this statement here identifies a definition of asset management in terms of engineering asset management, which is centered on the activities that provide the tools for production. That's the equipment that produces the product or the service. And that could be anything from a hospital to a road, to a manufacturing plant, to a energy distribution system. All of those, you could say, required tools. In the case of energy distribution system, poles and wires, transformers. All these things are the tools that allow that service to be provided, that energy distribution system to operate. And so the focus of asset management is on those tools, those things that are required by the organization. And the context for that then is what they have to do, what those tools have to do within the overall scheme of satisfying a customer's needs. So to understand what the tools need to be able to do, we first need to understand what the customers are expecting from the services provided or the products provided by those tools, and then work on how that can be achieved for the most cost-effective way. And so that also comes to focusing on the competitive strategy of that organization. So we're normally interested in connecting the competitive strategy of the organization to the tools that are used to produce the products that satisfy that competitive strategy. And that could be explained in a simple diagram where our focus is on the whole life cycle of assets, from the conception of the asset to the procurement of the asset to the operation of that asset and the maintenance of the asset, which would generally be in a cycle, and eventually the disposal of the asset. So we're interested in all of those activities related to assets. And it begins with the asset related activity, demand generation. So we've got a demand for an asset or an action on an asset. We need to design these processes so that that demand can be satisfied, and the output is asset performance. So we're interested in that flow from demand generation through to the asset performance against that identified demand. So they're the general technical processes that every asset works through. We're interested in the management of those activities. So we're interested in feedback from asset performance. We're interested in directing how these processes should occur, and we're interested in providing these processes and providing these particular activities that allow the assets to perform. So these are our main interests: the asset management system that looks at feedback, compares that with what's required, and makes adjustments to how things operate, and also feeds into decisions of the types of assets, particular asset selection that we need to allow these asset related activities to be performed. So that's our focus, and our connection is with the organization management system itself. So we're also interested in how we get information from the assets to the organization so that they can decide on the long-term performance of the organization, what investments they might have to put into the assets or the tools that they need to perform the work they need to, and so they get feedback on that. They also provide information back to the asset management system on what performance assets are required to provide. So that's engineering asset management. I want to move on quickly to touch on 4 areas that we've in a bit more detail that we've done research on. And just to mention that time is short, but if any of these are of interest to you, or any of those that I've mentioned previously, then please get in touch and I can provide more information, papers and other information on any of these research projects. It'd be great to have some collaboration as well in any of these areas that are common or complementary to some of the work that you're doing. So the 4 I wanted to mention, first was to look at degradation modeling. The second one was associated with the management system that I just mentioned. The third one was to look at asset selection and in particular context. And the fourth one was this production line processes, to look at one of the projects that we did here. And you might notice that these research projects fall into the category of both academic and professional research. So it follows the range of topics that we're talking about in the conference today. The first one is within the context of energy pipelines, and Australia is, whilst having a huge orders of magnitude less population than Indonesia, on the other hand, has significantly more land mass. And I guess a problem for us is getting resources economically to the places where people are, and one of those resources, of course, is natural gas, which we have some of. We have some significant fields producing natural gas, and we need to pipe that. As you do, you have significant energy pipelines also. So the context is these pipelines. The economics of the pipeline mean the wall thickness of the pipeline has to be contained, and other aspects of the pipeline really do drive the cost of providing this gas as an energy to the centres where it's utilised. And a large percentage of the cost of the gas is actually generated by the maintenance of the various systems, and particularly the pipelines that carry the gas, that transfer the gas from the generation site to the distribution areas. So then the pipelines are aging and degrading over time. There's quite a significant length of them. There's no way really to determine the integrity of the condition accurately. We always have uncertainty in terms of what anomalies are in the pipeline, and also how fast they are degrading, how fast they're growing. And they're critical to understanding when the pipeline needs to be replaced or repaired, and whether the pipeline is in safe condition. In other words, its integrity is a critical aspect, of course, for gas pipelines that do from time to time explode and cause horrendous damage. So the particular area we're looking at was degradation modeling. So that's estimating the time to failure of a particular section of pipeline. And the good thing is that there are lots of information, or data at least, generated by pipeline inspection. So inline pipeline inspection can be carried out every few years. It's an expensive activity, but it provides a significant amount of useful data, providing it can be interpreted properly. And our interest is interpreting that data. This is a representation of the data. So the blue and the red, the blue dashed line and the red line are the limits of allowable anomaly in terms of the length of the anomaly and the depth of the anomaly. So at particular sizes measured by length and depth, the anomaly is dangerous. It could create a situation where there's a rupture of the pipeline very quickly, which is an explosion generating event. Now, the red dots represent what the measurements are for existing anomalies and existing defects in the pipeline. And the blue ones might be a prediction of where they might be after a certain amount of time. So that was our project. we then looked at to actually analyze the data, we needed to use hierarchical Bayesian approaches, and we compared various methods for doing this to try to estimate things, because the uncertainty was in the location of the anomaly, whether successive measurements of that anomaly were for that particular anomaly or another one, and what size the actual anomaly was at the measurement stage. So all those were uncertain. Then, of course, from that uncertainty comes how quickly is this anomaly growing? And so we're basically using successive measurements of the anomaly, try to predict the future. And we compared a few different methods, utilizing information from all anomalies and also information from the actual anomaly we were looking at, and looking at how we could combine that information, taking some parameters from the population, some parameters from the existing anomaly, and try to predict what the future growth rate might be. And in this case, the result was that we found that dynamic linear modeling was the most accurate or the best way of predicting the future growth. So this is just showing a bit of our work, comparing different modeling techniques, utilizing data, and trying to then predict for the future what the, in this case, the age of the pipeline would be at a particular anomaly depth, which is, of course, very important to understanding how often we have to inspect the pipeline and when we should organize for repairs or refurbishment, given all of those things are quite costly activities. And this shows one result showing the growth over a period of 40 years, which is a long time. And you can see that there's a prediction that at least one anomaly will be on the limit after that period of time, which sounds like a long way away. And it is in this case, but again, we were dealing with fairly young pipelines. Just quickly, then the conclusions were that dynamic linear modeling was more flexible than the gamma process, and that structure allows consideration of multiple anomalies, and measurement error is critical. Now, I'll just move on. So in a similar way, we looked at railway bridges. In this case, the difficulty was that the data we got was simply inspectors' views of how close the bridge was, or the particular defect was, to a failure. So we then had some pretty poor data, but we managed to get, again, a better approach. This multi-criteria Markov approach seems to give better results than the methods so far identified. Moving on to area 2 quickly, looking at the overall process for a person within a pipeline industry, trying to make a decision on when to inspect the pipeline, when to repair it. Again, we utilize the degradation information that we've generated from the other research project, and developed methods of predicting what the overall performance was going to be, and compare that, present that then as a cost equation, and identify the best time to replace the asset based on the population of anomalies and the proximity to their time when something had to be done, and looking also at the various costs involved in increasing the number of inspections versus replacing a section of the pipeline. So we managed to present to the decision maker information on what they need to do. Area 3, we looked at making decisions between different types of structure for a railway line. In this case, we're looking at a range of things, how it's operated, the geology, the terrain, the available capabilities. All of those things affect the choice of a particular type of structure for the railway line, and that's what we were called on to look at by the industry. and we're still involved with this, trying to understand the quality of the available data and fit the models to the data that's available, not hope that the data is there, but work from the available data and develop models that extract the maximum amount of information concerning which particular track form would be the best for a new application. So the proposed models looked at costs in 3 areas of the life cycle: the construction costs, the maintenance costs, and also disposal costs. Some of those things may or may not be significant in a particular situation, but of course, construction costs and maintenance costs are very important. And we used just to explain our approach very briefly, was to look at staging different models depending on the available data. So if there wasn't much data around, then we developed an aggregated empirical cost model. If there is data on individual activities associated with different types of track form, then we can use an activity-based model with parameter costs and activity-based costs and frequencies. And if the information is there and the situation indicates it's valuable, then the third method of an engineering model with degradation data at individual component level, we develop models that allow, again, life cycle costs to develop in much greater detail. So this was the increasing complexity depending on if more data is available. And the results were, again, useful, indicating how life cycle cost would generate over time and allow us to compare them. And just briefly, in the last few minute that I have, we also looked at productivity measurement, as I said, on a production line. We looked at various types of events: order change, raw material loading, and production time, and looked at how those affected the costs. And we could then use that to reflect then the overall effectiveness and look at comparing order sizes and other things that were at the discretion of the organization to see how those things affected productivity and start to focus the improvement program on that. So in closing, just the overall conclusion that asset management is a key component of any organization, particularly for asset-rich organizations. That's much more important. But research in this area must take place within industry. Can't take place in a laboratory usually. It relies on data from industry. So industry needs to be interested in the project sufficiently to assist with data provision. And I find a very important and also interesting research area. Okay, thanks for your attention, and I look forward to the question and answer session.
Okay, thank you very much for the prestigious presentation. So let's give once again a big round of appreciation for Mr. Richard Dwight, PhD. A virtual applause may be applied. Okay. Now, ladies and gentlemen, let's welcome our second presenter, and he will deliver a presentation entitled Git Build Concept Map, the Composition of Concept Map for Learning and Evaluation. For Professor Sugasai
Okay.
Dasina.
Thank you very much.
Again, at the time.
Can I see my slide?
Yes.
Okay. Selamat pagi, everyone. So I'm Tsukasa Hirashima name. I belong to the Learning Engine Laboratory in Hiroshima University. Today I will talk about my research topic. That is okay. So based on that, my research topic based on information technology, I try to develop and then create an innovative learning and teaching. So I will introduce based on that information, but based information technology. But target is learning and teaching for my presentation. And then, so today I'll introduce one topic about the concept map. And then some, but not only a usual concept map, but here is I building and then researching about a framework of recomposition concept map. I mean, usually concept map is created by individual, by learner or teachers to represent their understanding. But here is, we request students to recompose. I mean, if the good concept map, there is a good concept map, or teacher has a good concept map as a representation of his understanding, in that case, to share that is very good, good thing. So in such case, to recompose the concept map of teachers one to from nodes and link, it's a component, is a very good approach. So we confirm that. So through the research, and then that is the meaning of the concept map recomposition is understand other understanding. So so that framework I say that kit build concept map. So I try to introduce the kit build concept map and then the background and the theory, and then I will provide the opportunity to use kit build concept map. It's a very simple one, so I ask you to use later. So to contact us, use that web-based kit build concept map. And then now this is I explained that from the viewpoint of support of learning and teaching, but not only this is also use the consensus building. So that means kit building is a consensus building teacher and student, but peer-to-peer or usual community. So this is, I think this is very useful to consensus building of prior knowledge as preparation for discussion. So if you don't have not so much interest about the learning or teaching, but maybe anyone, all of us use a meeting or some community. In that case, please think that this approach, kit build concept map, can be used for your community or discussion. Okay, so firstly, concept map. Maybe concept map is very famous, and then I have many collaborative research with the Indonesian researchers. But so they say that it's very common in concept map. But so this is a concept map is very about the concept map. So the very famous one, and then that is a concept map is a graphical representation of understanding. So someone has some understanding. In that case, they can represent that graphically in concept map. So that is usually concept map is a representation of understanding. And then that is in the concept map node and the concept, and then link with relation between concept and between concept. So and then so that is a concept map, and then usually create that concept map to represent their understanding. But if the concept map is useful to represent the comprehension of learning targets. For example, this concept map is a concept map of concept map. And then so this is Professor Novak made this, and then sometimes introduce that is a very basic knowledge about the concept map. In that case, to share this concept map, not only to make is not enough, but to share the concept map is very useful. So, and then, but how to share it? Only to see the concept map is to read or to understand the concept map. So to show only to understand, it's not so easy. So our method is, okay, recompose. And then to recompose the concept map, in that case, so the person to recompose should know the component and then relation. So, but even that provided the components, to recompose is not easy. And then someone can recompose that. In that case, almost we can it's mainly almost understand about the represented concept map. So that is a use of the recomposition of concept map. So I will explain that in more detail. Also, use a very simple concept map. So I mean about the sugars sugar and sucrose and glucose and fructose. So that is I can find that a relation in the textbook about the sugar. And then in that case, there's a 4 nodes. So then sugar, sucrose, glucose, fructose, and then 4 links. So it's made of or changed to or related. And then so based on this, so there is a 4 proposition. So sucrose related to sugar or sugar, sucrose is made up of fructose or something like this. So in that case, that means so in the Kittville concept map. So firstly, this is a concept map and then represent a good understanding. Maybe, for example, teacher hope to the student to understand like this. At least students should know this. So in that case, decompose this concept map. So the concept map is composed of node and links. So by decomposition, so that means node and links is generated from this concept map. And then so provide a learner, student. And then in that case, okay, so of course, basically after the lecture, so student is requested as teachers to decompose that. And then, okay, the student make this. Then sometimes mistake. So even that, so teacher may, of course, teacher explain this and then provide a component, but sometimes, and then in the practical usual classroom, so some of them cannot decompose. In that case, some of them is not at student make different, cannot completely decompose the concept map in the same one. So in that case, that the difference between two maps is difference between the two comprehension. So teachers think of this, but the students cannot make in the same way, other way. So in that case, the difference is difference of the understanding. So in the case of teaching or learning, in that case, teachers should support their correct or improve their understanding. And then use a communication in usual communication meeting. In that case, it's necessary to discuss. So that means there is a difference of their participant understanding. So this is a basic meaning of Kittville concept map. So again, I said that firstly, teacher make a concept map. So about his lecture, and then so make a Kittville component is generated, and learner is requested to decompose. And then, so by comparing that the two concepts, original concept map and then decompose concept map, we can derive easily to the difference. And then based on that, so we can give a feedback for students, learners, and then guide them to improve their differences. So this is a Kittville concept map. And then so I mean that is a map. So it's like it looks like a graph, but it's easy to automatically diagnose that the automatic assessment is possible. So I try to explain that means. So in that case is like a graph, but basically decompose is not a different characteristics. So teacher, so in that case, teacher map and then learner map. So decompose. In that case, the node is same. All node is same one. So teacher make map, and then student can use that only allowed to use only the component that the teacher used. And then so link also same. And then only the link location is different. And then so that means to compare this map and this map is only to the link location. So which link is pair? And then only the link is limited. And then of course the location is also limited because of defined by the nodes, two nodes. So in that case, which node link is different in between teacher map and learner map, and that so easy derives the difference. So by unit operation, so easily to find the excess link. So I mean the excess link is not included the teacher map, and then what missing link is not included the learner map. So easily to find. And then one more important characteristic of Kittville concept map means it's possible to overlap several maps. For example, there is 3 students, and then they make their decompose their own map. In such case, so it's possible to overlapping their map. So because the node and links are all the same one, so in that case, it's easy to overlap. So by overlapping, so for example, these three map, so like this map is can be generated. So that is a group map. And then, so this means all student is connected this like this link. And then this is, and then this one. And then, but about that, this link is only one can connect it. So in that case, this one is the same with teachers, and this one same with teacher, but only one. So in that case, this connection, so this proposition is a weak point for the students in the class. So teacher should support them. And then about this, it's not necessary. So by using this key concept map, so teacher find a weak point of students as a group, even in a group, and then also confirm that which part is no problems. So that is a very important point. And then it's a teacher and student case, but in the communication, usual communities discussion case, maybe it's a to make an agreement case. In that case, so these are almost agree, and about that is also agree. So we can easily define. So that is the important feature of Key2 concept. And then I will show the example of using. So basically, we use the Key2 concept map in school. So I will show example of that. So I mean that is so we have already you build that system, the Key2 concept map system, and then using this is an elementary school. This is a case use elementary school about maybe that is a 4th grade students in the science learning. And then in the science learning, teacher basically teacher already teach about the about the target domain. And then after that, as a confirmation of the student understanding, so teacher requests to decompose the component and make a concept map. And then, so now this case is use a tablet. So of course, any kind of computer or desktop, okay, no problem. But here is use like this. And then later I will ask you to try to make. In that case, that is an online web-based one. And then so now is a communication scene. So I mean, basically each of them to recompose their own concept map. But here is student to collaboratively change. So I mean, how to make or how to change, how to make the create the same map or how different is discussed. And then now is in this time we have collaboration is it's offline, so necessary. But now, so we have already implemented that online collaboration function. So later I will show that in that case, in the practical use case. Okay, so I try to ask you, so if you can have you can use that. In that case, please try that. And then, of course, I try to introduce a demonstration. So if you cannot access that, in that case, I will see my demonstration. And then now, I try to make a concept map about this sentence. So this sentence is very small. So this is the example. So this is a very small one. And then, so the 4 main islands composed of Japan, Hokkaido, Honshu, Shikoku, and Kyushu. And Tokyo is Japan's capital city. Kyoto was the capital city of Japan for over 100 years. So we make this, so the content about this sentence, we make a concept map and then make a component and recompose that. That is this time's example. Okay, so I will, okay, so let me, wait a minute. Okay. So I will send this one is a URL of a system. So I will send this in the chat. Oh, wait a minute. Here I can find the chat thing. Okay, wait a minute. Sorry. I should find the function of chat. Okay, here. Here. Okay, okay. I send the URL. So, and then if you can use that, please access about this.
I will try to help you.
Yeah, please try. And then, so if you click that that's URL, you can see like this scene. So screen, but so please input your nickname. So nickname. So later, so I will show the analyze results. In that case, maybe so the name is appeared. So if please use that name, that is not so problem to appear after the analysis at the analysis. So let me keep. Okay. So I send that in my name. And then so only to give a name and then okay. In that case, you and then welcome. So the nickname and then so in that case you can find like this component. So now it's not a full compose. So I mean, so all component is decomposed. In that case, it's a little difficult. So that means some of them is connected or already connected. So I will say that is partial decomposition. Okay, and then so this is a concept map, and then this gray is a link, and then you can find by clicking this gray one, you can find like this circle, and then you can use this, for example, connect like this, or like this. And then so I tried. Maybe some of them you can without a text decompose that, but you can check that the text. So you click by read, you can find that the text that is next. And then if you can access, please make this. And here is, of course, okay, about this is this is an example. So I will some propositions, so some information is lacking in here. So in that case, you can decide by yourself. And then, for example, like this, so let me. Okay, so the ancestor capital. So ancestor capital is here is so Kyoto was the capital of Japan for but was so let me past the capital. So this is a Kyoto connected. And then so let me main island. So that means Honshu, Shikoku, Hokkaido. Here Honshu, Hokkaido, Honshu, Shikoku, and Kyushu. So here is not Kyushu, but so I mean that is not a given name. So in that case, that is use that in the classroom that as a question. But one more is maybe this is Kyushu. In that case, it's connected like this. And about this, so most attractive city for me. So now here is not included here, of course, and then you can select by yourself. So let me. Maybe you can, in that case, only cities too, but you can connect here, or you can connect here, or don't connect is also you can select by yourself. And then okay, this main island here, and then so and Tokyo is in which island? So it's there is no information, but so you can decide by yourself. So maybe okay. So for example, I mean, so in that case, that it's not provided the information, but how they conducted. That is a one important way. Okay, and then this is a concept map. And then one more thing I will introduce in the collaboration. Okay, so let me so maybe you if you are using this system, so if you connect room, so in that case, Tsukasa's room. So that is I make my room. So in that case, you select this. So enter the room. In such case, So that means it's a collaboratively recompose this. In that case, so here is this the one, and then so other, okay, okay. So here, okay, someone, okay, for someone including that. So for example, I'll make this. This is I enter the this room. So other users. In such case, so that means collaboratively use this. For example, so operate this. In that case, we can find this. So that means this is a collaborative decomposed function.
Sensei, your screen is not moving. Do you actually make
cannot.
this?
Okay, sorry.
Yeah, maybe you are sharing the incorrect screen.
Okay.
I'm so sorry.
Sorry. Okay, now you can see this. No? Okay, wait, okay. Sorry, I mean, again, I will share this. Now you can see this.
Yes, we can see.
Okay, so sorry.
So sorry.
Okay, so I mean, so cannot see that my decomposition process also. Okay, so now, okay, let me by making this, for example, so I will explain again. So let me by clicking this gray one, and then it's possible to connect to this one. Okay, like this. And then so let me please connect that. And then I will try to explain again that collaboration case. So if you enjoy, okay, now is 7 7 users in join this room. In that case, so that means by using that someone operate this. In that case, others can see this. And then we can about this. So give a message. I do connect this. In such case, so that means text-based collaboration. So I give a question about that. Someone make this connection. In that case, so that means like to confirm that the reason to connect. In that case, give a message. In that case, others here, this user also can find this. Yeah, okay, fine. And then because like this, because I explained that. So that means we have already used that like this collaboration. And then in the case of kit building, so the component same. So this runner, this users and this users make the same material and then same component. So in such case, very easily to discuss about this. So why you connect this or why you this. So, but in usual concept map case, so that means any participant use their own words or their own link. So in such case, a little difficult to collaborate because others, it's a little difficult to understand the meaning of the others map. But in this case, they use the same component. So they can easily tell why you connect. So I don't think so or something. We confirm that like this way. So the kit-build concept map is very promoted their discussion or good discussion of quality and quantity improved. Okay, and then this is a way to the kit decomposition. And then next is analyze their map. So if someone make this map, please upload. So upload means send the decomposed one to the server. So maybe that is a teacher. Submit the map. So okay, submit map. And then so after that, so the we can so teacher can analyze that. So because I mean students make a same component to decompose, and then as I said, a teacher can that system can overlap all maps. So what kind of maps they decompose is easily to find. So I'll try to explain that analysis. Okay, now so it's the previous one. So I try to map. So maybe this one. Okay, okay, and then now is a 5-person submitted that. So not so easy to use maybe. But now in that case, okay, so by overlapping all ones, so I mean like this map we can make as a analysis of all participants map. So that means maybe so okay. So how should I say that only to represent that correctly. So then correctly here means correctly means same with the teachers means only show this map. So maybe Japan capital city is Tokyo is all here is a 5. So that means all participants connect this. And then about Japan, Hokkaido is the main island. It's also 5 and this also 5. But about the most favorite city for me is Kyoto is only 1 connected. So of course this is not there is no information in the provided text, and then it depends on the person, and of course no problem. But we can find that is very not so much. And then about connection, this is not so much users use. And then this is a correct one. And then maybe missing link is more easier to discuss. Okay, so and then missing one. So about this, okay, so all participants don't link this. So I mean, Tokyo is in Honshu, but this is not included in the text. So maybe a little difficult to connect this. And then, so in the like this concept map, so we already observed that users or runners recompose is the easier part. And then remaining part. So last part is become difficult. So in that case, firstly, so I mean, about this is missing part of a small case. I mean, meaning that is more easier. But this is difficult for the decompose in this case. So this is a Key-to-View concept map meaning this. And then and then so I mean most of the so okay. And then about this, so I mean now so basically I said I mean teacher make this and then request student to recompose same way. But like this, it's a teachers set this to Kyoto, but others is also set this no problem. So I mean how to interpret that the recomposed concept map is depend on the teacher's principle. How teachers. So I mean if like a questionnaire. So, okay, how many participants think that the Kyoto is good, or how many participants Tokyo is good? Also, to gather such information, it's also possible to use this Key-to-View concept map. Okay, this is a demonstration of Key-to-View concept map. Okay, so maybe a little difficult to contact this. Okay. Okay, so okay. Then, so I will explain that what is the meaning of the Key-to-View concept map. So here is this is the meaning of Key-to-View concept map. So usually concept map Key-to-View concept map case someone maybe basically teachers or expert make a concept map, and then of course this meaning is defined by the themselves, and then this component is requested to recompose the same component. In that case, so this person try to decompose this one. In this case, in this person try to understand this person's understanding. So by using this component. So that means this is a recomposition concept map means understand the other's understanding. And then so maybe that the difference will be appeared in the about this difference is near to the difference of their understanding. So someone cannot recompose in the same way. In that case, about this, they too has a different understanding. So this is the Key-to-View concept map. But the usual concept map case, of course, it's possible to make this two person make a concept map and show these concept map and then discuss about that. It's possible, but this map was using this map and there was this map and very different, sometimes very different. In that case, that difference is not so directly means this difference over their understanding. So at least through the experimental evaluation, so critical concept map case is difference is very useful for support the discussion, but only to provide a concept map, each student make a concept map and then only to show each other. In that case, it's not so much promoted the discussion. So this is our result. And then one more is knowledge graph. So knowledge graph is also represent that like a network of the concept. But the knowledge graph case is meaning is defined by ontology. So this map meaning is defined by this ontology. So so if you case of knowledge graph case, so that means concept map is possible to interpret by using this. But to make concept map following this ontology is basically very difficult. So that is we don't use that ontology. So and then knowledge graph. So in that case, teacher make this and then students have to understand this. So that's very difficult in basically learning, or even in the community case. So to start to discussion, so they have to make a concept ontology is very not so easy case. So, but critical concept map, someone has understanding make map, and then based on this, we participants can discuss about how understand the same way or different. So maybe that is I believe that is a practical approach for make an agreement. Okay, so and then okay, so let me one say so let me I say about the critical concept map as a tool for learning and teaching, but this is also useful for concept building of prior knowledge as preparation of discussion. So any kind of discussion, so like this preparation is possible to use. So I hope you to understand similar. Of course, for the learning and teaching, of course, useful, but for the communication, so in the community discussion, so maybe I hope you to think that is a possibility to use. And then, so I mean, this KB maps research is very supported or many contribution from the Indonesian PhD students. So the mentor, so chairperson of this session, Dr. Andoko got a PhD about this research in 2020. And then we have already additionally three PhD students from Indonesia, so graduate based on about this KB map. And now it's two students, so that means studying about KB map in my laboratory. And then lead one is your universities come from your university. So now is working hard about the KB map. So now I like to say thank you for the Indonesian researchers and teachers and students, so contribution for KB map. And then if you have a chance to join our research groups. And then now currently we collaboration with Dr. Andoko. So please discuss about this if you have interest about this. Okay, thank you very much for your listening to my presentation. Thank you.
Let's give once again a big round of virtual applause for Professor Tsukasa Hirashima for the enlightening presentation. Thank you very much. And now, ladies and gentlemen, let's welcome our third presenter. He will be delivering a presentation entitled Power Flow Control of a Grid Connected Solar PV. Ladies and gentlemen, please welcome Mr. Ferdian Ronilaya, PhD. And Mr. Ferdian.
Can you see my slide?
Yes.
Okay, thank you, Mr. Bani. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Today, I will present my research entitled Power Flow Control of a Grid-Connected Solar PV. And before we begin, let me introduce my research activities. Actually, my research activities talk about solar PV system and power electronics, including DC to DC converter and also inverter. And also we discuss about power quality assessment. And these photographs shows some of our products that we have developed with our students. Okay, now we focus on my research entitled Grid Connected Solar PV. And in terms of grid-connected inverter, there are four main issues that we should consider. That is firstly efficiency, and secondly power quality, safety, and cost. For solar efficiency, as we know that it depends on several factors. That is firstly solar types and positioning, temperature, shading, or power converter design. And then in power quality cases, the integration of solar PV to a grid need compliance to several international standards. For example, in terms of harmonics, power factor, DC current limitation, voltage and frequency division, and so on. And for safety issues, for some cases, the inverter is using transformer. Why we use transformer? Because the transformer provide galvanic isolation. So between solar PV and grid is connected not directly in electrical network, but in magnetic coupling. And then for cost, we know that the overall cost of the overall cost of the grid-connected PV depends on several factors. That is, for example, the quality of the solar panel and size and the converter types that we use. Then we are talking about the structure of a grid-connected solar PV, and this figure shows the typical example of the centralized solar PV. In the centralized PV, in this tree diagram, we can see there are more of two modules which is connected in series or parallel in order to get the increased power output. And then after connected in series and parallel, because the output voltage is DC, then we need to convert the DC waveform into AC waveform. And typically, the inverter used in the centralized structure is full bridge configuration, whether it is 2-level or 3-level full bridge inverter. And then there is another structure, so-called distributed structure. It is different with centralized structure. As we can see in this figure, that the inverter is installed on the single solar module. So you can see the difference here. Okay, and in this configuration, the inverter is installed on a single module. And generally, in this inverter, we can also find the MPPT algorithm to increase the efficiency of the solar PV system. And because it is installed on the single solar PV module, then generally this inverter is small in size compared with the centralized structure. And then we talk about the inverter topologies, and this figure shows the example of isolated inverter topologies. The main feature of the isolated topologies, we can see the existence of the transformer. Every circuit, you can see the inverter over here. And figure A, this one, is an inverter interface with low frequency transformer. And generally, this transformer is quite large and weight. So we will have a higher volume and size if we use low frequency transformer. And then figure B shows a topology that increase the DC voltage come out from the PV module by using high frequency transformer. And then figure C is the single stage topology without DC to DC converter. And typically this transformer use flyback transformer. And then figure D shows us the two-stage inverter topology with high frequency transformer in the grid side. It is different with figure A and D. In figure A, we use low frequency, and in figure D, we use high frequency at the grid side. And then the topologies that we have talked before is based on using transformer. And now we are discussing about the transformerless topologies. The transformerless topology means that we do not use transformer as an interface between solar PV and grid. And even though the isolated inverter topologies are accepted as an industrial standard in terms of galvanic isolation, the transformerless inverter have been proposed for decreasing costs. So why we use transformerless topology? Because the reason is decreasing cost. And then the second reason is we can decrease leakage current. And the third reason is increasing the efficiency. And the use of transformerless inverter may decrease leakage current. And we should note that the leakage current causing several issues such as safety, electromagnetic interference noises, and also we will get higher THD level. And then now in this slide, we will discuss regarding the various inverter circuit that we have found in the literatures. And figure A and B are the example of string PV inverter topologies. String PV means that we will find more than one solar PV module in the circuit. And also figure B, we can see more than one module connected in series or parallel. And in general, figure A and B has very big in size and very heavy, because in this case, we use low frequency transformer. And then figure C, for here, D and E, in this configuration, we use high frequency transformer. And this one, C, D, and E, generally called as micro inverter, because this inverter is installed on a single module, solar PV. We can see the difference over here. And sometimes we also find the MPPT algorithm inside this inside the inverter to increase the efficiency. This is the example of isolated topologies because the existence of the transformer. And then we talk about the transformerless topology. In this topology, we do not use any transformer installed in the inverter. And figure A until D, A, B, C, and D, used for string solar PV system. And then figure E is the example of the circuit that is used for microinverter because it is installed on a single module of solar PV. And then another important issues of solar PV system relating to the efficiency is maximum power point tracker, or we call it MPPT. And as we know that the goal of MPPT is to detect maximum input power corresponding to any fluctuation on source voltage and current. And even though the MPPT algorithm targets to maximize efficiency, it will not properly work if both stable and varying conditions are not tracked. So the role of the MPPT is to track the point that we will get maximum power from the solar PV. And if we categorize the MPPT, we can classify it into direct MPPT and indirect MPPT. The direct methods are operated by detecting PV voltage and current. So in direct method, we use voltage and current sensor directly. Meanwhile, in indirect methods are based on the calculation. So it is based on the prediction, the value, voltage and the current is obtained by the prediction of any calculation. And because we use indirect method, because we use sensor, it means that we measure directly the value, and then as a result, we can get the time response will respond quickly because we do not use any calculation. And then if we look at this figure, we can see that when the current, this is the typical characteristic of the solar PV. ESG means short circuit current, VOC means open circuit voltage. Okay, and because at this point, for example, at this point, we will get maximum current output of the solar PV. However, the voltage will be zero. So as we know that power is multiplication between voltage and current, so the output power would be zero. And then at this point, open circuit voltage, we will have higher or maximum voltage, but the current is zero, and the product of V and E would be zero. So at this point, the solar PV should be operated at the maximum power point, and then it is the role for the MPPT to track this maximum power point. Okay, and in literatures, we will find a lot of algorithm how to detect the maximum power point of the solar PV characteristic. And this is the two figure that show us the effect of irradiance on the current, and this is the effect of temperature on the voltage. As we can see that if we have a fluctuated irradiance, and then we will have fluctuated current. If we have decrease irradiance, if the irradiance decreases, then the current would be also decrease. In the contrary, with the temperature, if we have the module temperature is high or higher, then we will have the output voltage of the inverter will be decreasing. So irradiance give a significant impact on the current, but the temperature will give significant impact on the voltage. And then this is the various type of the MPPT technique in terms of response time, complexity, and measured value. And in the market, the constant voltage, open circuit voltage, and short circuit current MPPT are widely used as a direct method because its simplicity. And then for more advanced algorithm, we will have perturb and observe algorithm, or maybe incremental conductance. And of course, we will find a lot of MPPT method, but we should consider the response time and complexity. And of course, we should consider the cost. And then this table represents a summary of international standards which should be followed to ensure the grid, requirements. And the most important issues that we should note that firstly, harmonics, DC current injection, voltage deviation, or frequency deviation. Especially for transformerless topology, the injection current ratio is the most important issues. It should be lower than 1% of rated output current. This is only for transformerless topology. And then now we continue to the inverter controller. It is comprises DC side and AC side controller. Since the solar inverters are responsible for connecting to a grid, then we need these two separate controllers. The first one is located at the PV side. This is the PV side. And the second one is located at the grid side. And the PV side controller are responsible to detect the maximum power point of the solar PV by using MPPT algorithm. On the other hand, the AC side controller are responsible to improve the power quality and efficiency also. And then the important thing is the AC side controller here is responsible to control the active or reactive power flow. And this one is one of the tabel that represent so many work that have been carried out by the researchers, and the application we can see over here. Several applications that is firstly for UPS, PV system, or fuel cell, distributed generation, and so on. And now this one is the power flow control, because as I mentioned before, the main role of the AC side controller is to control or to regulate the active or reactive power flow. So we need to discuss this point. And figure A shows an electrical scheme of the single phase inverter, which is connected to the grid. And this scheme is modeled by electrical equivalent circuit by this simple circuit. And then we can analyze the relationship between inverter voltage, grid voltage, output current by using these phasor diagrams. This is the grid voltage that is used as a reference, and this one is the inverter voltage, and this one is the phase angle between grid voltage and output current, and delta or power angle over here is the phase difference between inverter voltage and grid voltage. And if we look at in detail that by using these phasor diagrams, we can see the relationship between inverter voltage and power angle is like this. VL is drop voltage in the inductance. And then if we continue to solve this equation, then we will get the equation of the current injected to the grid like this. And then what about the power injected to the grid? We can solve it by using complex power by using this equation. Inverter output voltage multiplied by output current. This is the complex power. And then if we classify it into a real power and imaginary power, we can get the power, active power like this. This one is the equation of active power, and the third one is the equation for the reactive power flow. And from this equation, we can conclude that actually we can control active power by regulating the phase difference delta. And also we can also control active power by regulating the inverter output voltage. Okay, and this concept used for us, we use this concept to construct or to develop the power flow control for a grid connected inverter. So in this case, we use two parameters as parameter regulator, that is phase difference and inverter output voltage. And this one is the block diagram that we have developed to implement our concept. This one comprises so many components. For example, phase control, we use very cheap op-amp integrated circuit LM741, and then we also need triangle waveform and so on. And then this table shows the specification of our inverter. And then this is the circuit that we have developed, and then this board shows us the PCB layout that we developed. Actually, the size of this PCB is relatively quite large, maybe around 20 to 25 centimeters and at height, and the length is also the same, 25 centimeter height. Maybe in the future we will construct any more compact PCB layout so that we can decrease the cost. And this one is the prototype that we have developed. This is the PCB, and the top view of the product that we have developed is like this, and this is the front view of our product. And this is the cover that we use 3D printing to implement or to develop the cover. Actually, the cover is not good enough. Maybe in the future we should find any ergonomic design so that the prospective consumer will interested to buy our inverter. And this guy is my student that work with me, and now he is working at Japanese power plant company in Center Java. And this is the scheme of for the experimentation, and we will go quickly. And now we talk about the experimental results. And this figure show the voltage profile of the output inverter and grid voltage and inverter voltage. And the green one is the grid voltage profile, and the yellow one is the inverter output voltage profile. And we try to test the inverter if we have leading voltage that is 15, 25, 35, or maybe 45 degrees. We can see in this figure the fast difference between green one and the yellow one. And this one is the voltage profile and current profile where we test the inverter by leading 15, 25, 35, and 45 degrees. The yellow one is the voltage profile, and the green one is the current profile. So it is why the magnitude is lower than the yellow one, because this green waveform is current, not voltage. And then after we have a test result, so many test results, and then this one is the result of the inverter. And these two figures shows the relationship between a variation of power angle. This one is power angle, this one is active power, and reactive power is shows in the second photograph or second graphic. If we increase the power angle, this is the power angle, and then we will get a higher active power, and it corresponds to this equation. At the same case, if we increase the power angle, then we will have a higher reactive power. After 50 degrees, then the reactive power flow will decrease. And this one is the power factor profile under various power angle. And if we increase the power angle, and then the power factor would be approaching to unity power factor. It means that the unity power factor means that the more active power would be delivered. And then the second graph shows the relationship between inverter voltage, this one is inverter voltage, and the power factor. As you can see that if we increase the output voltage of the inverter, and then we will have a lower power factor. It means that lower power factor means that the more reactive power would be delivered. So in this case, we can conclude that developing control algorithm by controlling fast difference and inverter voltage would be one of alternative to control power flow of a grid connected inverter. And of course, if you try to find another or the other power flow control method, you can a lot of methods or strategies, and we can try to find which is the optimum controller that we can implement in the inverter so that we get decrease cost in the inverter. I think that's all of my presentation, Mr. Bani. Thank you very much for your kind attention.
Okay, thank you very much for all the presenters for their informative and interesting talk. And very well, ladies and gentlemen, now we've come to the question and answer session. So this session will be divided into several sessions until the time is at. And I would like to open for the first session, and for every participant who would like to give a direct question, you may raise your hand by using the raise hand function in Zoom. And looks like that we have several questions in the chat room. So firstly, I would like to go to Mr. Richard, our first presenter. So looks like Mr. Ari gave several questions for Mr. Richard. The first question is, what can be measured if we want to develop a supply chain management system?
Okay.
Okay. Do you want me to finish my question first, or you would like to answer directly after my question?
Go ahead. Go ahead. Yep.
Okay. Okay. And the second question would be, you are mentioned about anomaly in reliability assessment. So what kind of anomaly that usually occur in that assessment? And the third question would be, for common people, if interested to conduct research in asset management, so what is the most important step that we should do for the beginning if we want to conduct such a research in assets management?
Okay. So the first question, my specialty is not supply chain management. So I need to say that first. We do have a person who does specialize in supply chain management who I can forward that question to. But just thinking about it, I guess in terms of a supply chain, we're interested in how things are flowing through the chain and who's extracting the most value from the supply chain. But in terms of how it's operating, I guess we'd want to be monitoring stock levels and lead times, how long something is held within one organization before it's transferred to another, the rate of consumption. So I guess some of these things would be difficult to obtain depending on the agreement of the various organizations within the supply chain. But thinking about it, some of those maybe are directly available or could be inferred from some members, and we don't need everyone to agree. So anyway, they were my initial thoughts for that question. I hope that helps. The second question about anomaly pits, I just can share this one. What we're talking about is just initially marks on the internal surface of the pipeline. Might be like this, could be from defects during manufacture, or we're more interested in these sort of defects from corrosion, so for corrosion of the metal. Yeah, so the reason we call them anomalies rather than defects is because sometimes they may not be a defect, they may not be something that's going to grow over time, but they still might be an indication on the measurement tool. So we need to be clear about what the measurement tool indicates, and whether that's a defect or not is another question. So that was the reason for anomaly. But generally, for the inline inspection of gas pipelines, we're talking about these sort of corrosion-related pits in the surface of the metal. But that leads to the second picture there. So if the pit gets deep enough and wide enough, it could lead to this type of failure where the whole pipeline starts to split, but not just slowly. It happens at the speed of sound or faster, and so you get gas projecting there, and the crack propagates at a certain rate, depending. If it propagates more slowly than the pressure reduction, then we get the crack slowing down and stopping. But if the crack precedes pressure reduction, then the crack could continue for a long distance, and you end up with this catastrophic failure like the one in the bottom right hand of the screen, where you've got huge explosion, and in a city environment could be very very catastrophic to life and infrastructure damage. So that was my question on what's a defect, what's an anomaly, sorry. And the last question in that group was about if you're going to conduct research in asset management. I guess like all research, it's the first step is to start to read some articles, some papers, recent papers in that particular area, in this case in asset management, and start to understand what the issues are, what people are working on, and where those problems are up to. Where's the current status of knowledge? I guess I'm not telling you anything terribly different from any other discipline, but for me, my interest came from actually being involved with engineering asset management, and identifying that there was a limit to the amount of science that actually was available for people to utilize in trying to improve how they worked within industry, and how problems were solved, and how predictions could be made, and better decisions made. So I guess my initial interest was based on experience trying to actually perform asset management, and that led to that sort of search for what's the current knowledge. Is there some ideas out there that similar, have people pursued the sort of ideas that I might have been thinking of, and what happened with those? Were they successful or not? So that was I guess, hopefully answering that question in a particularly general way.
Okay, thank you very much for your informative answers. So I would like to ask Mr. Ari, is it enough for the answers? Okay. And now we are moving into another question. So this question will be pointing to Professor Tsukasa Hirashima. So there are several questions for you. So the first question is coming from Hani, and she is questioning, and her question is about, why do you choose concept map as one of your research area? the opportunity conducting the same method with concept map is still available. So what do you think?
Okay, so basically to me, concept map is a very general representation method to for the understanding. So I mean, maybe concept map is almost same as a semantic network, and then semantic network is a general representation method in symbolic artificial intelligence. So by using the concept map, almost the same can represent. So that is a general way. And then, so my other research is about that, for example, the other research area or specific for domain, for example, arithmetical word problem or specific science domain or something. In that case, we use more specialized representation method. In that case, that is more effectively represent that. But in such case, the depend on the domain-dependent model we use. In that case, that the result is only to use for domain. So, of course, that is for me, that's very interesting and use, for example, the support system for word problems or mechanics problem or something. In that case, that we prepare the specific representation for the specific area. But one more research approach, so try to use a general method. In that case, as a general method, concept map is a very general one. So because I use this. So in that case, by using a concept map, so by using concept map requests to teachers or experts to represent their understanding, in that case, any area, mathematics or science or more social, many kind of subject to teach is represented by the semantic network, so concept map, and then apply by using this, we can conduct it classes by using KB map. For example, the English, so that we, Dr. Andoko used for the Kitty concept map for the English learning. So, for example, so that is very easily to use for that. So that is one way to use a concept map as a general one. So I mean, the other researchers, PhD students use that is programming, so conceptual understanding of program. But also we can use for the English learning. So that's both cases possible by using concept. That's the reason we use that concept map. And then maybe still available. So I mean, that is a many possibility use a concept map to, and then usually to make a concept map very popular way for learning, but to diagnose the created concept map very difficult. And then so that is automatically, or human evaluation also very hard, not so easy. But Kitty concept map very automatically evaluate that. And then through our researches, we confirm that Kitty building is enough learning effect. So basically not necessary to student request to create a component, because usually in lecture, teacher provide a component, and then teacher requests them to organize or make a structure based on the component. So in that case, Kitty building is enough. But if the student can understand each component itself, in that case, a very beginning problem for me. So in such case, lecture itself, student can understand. So that because I believe so, recomposition is cover many kind of learning request. So I think that is Kitty building is, and then recomposition concept map is a very good approach. And then if we extend that, recomposition itself is very important. So maybe we have some structure. In that case, so decompose that and then decompose the learners or other partner. In that case, they can share the understanding or not easily to find. So that means decompose and recompose is a very good way to confirm others' understanding. So that is my answer for that.
Okay, thank you very much for your answers. And maybe this is a light question for some participants, such as, and if what make you interest in conducting research in technology enhanced learning? So why do you choose technology enhanced learning for your research area? Do you have any
Okay. Okay. So basically, my very basic background is symbolic type of artificial intelligence.
Okay.
So so currently artificial intelligence is statistical type of artificial intelligence very popular, but my background is symbolic type of artificial intelligence. So symbolic type of artificial intelligence try to represent a knowledge as a symbol. And then by using a symbol, conduct the infer some others. And then so I mean that process is very and then that is one of the viewpoint about that is that is a model of human thinking. So that means symbolic AI is try to simulate that the human thinking. So, but the viewpoint of symbolic one. And then so that is started. Then and then my interest about that, why students make a mistake or miss wrong answers. And then that's also simulated by using that the student has wrong answer, wrong knowledge. In that case, student make a wrong answer as a logically. So you can make it understand. So our viewpoint is that my research background is student is logical, but the student has a wrong knowledge or wrong recognition of a problem. In that case, they can derive the wrong answer logically. So that is my main model of a started point of my research. And then so how to use that? Okay, that's education. Or by using that, we can improve the learning or education. So so why I use that means first interest for me is how to simulate human thinking or humans' wrong answer. And then next step is okay by using that. So what is the ability? How to use that is okay for learning support or education. So that is a process by selected technology enhanced learning. So at that time, so very old one. So we cannot use that directly. But now I feel very interesting. So we can use in the classroom now. That's very different. So that when I started that it's very impossible actually. But now we can use that. So my students is very willing to use that because software directly get a reaction from the students. So that's very impressive for us. But that's a risk.
Thank you very much for the interesting answers. And now we are moving to another presenter, and we have several questions for Mr. Ferdian. And for the first question coming from Mr. Januar, the question is, do you think solar PV research could support the renewable energy? So if it could support the renewable energy, how long would it take to become the usable product of renewable energy, based on your opinion or experiences?
Okay, thank you, Mr. Zanwar. About PV research, I think, PV research could support the renewable energy. I think, yes. In my opinion, yes, we think that PV research would support the renewable energy development actually in our country. As we know that the solar panel price is now decreasing year by year. Maybe we know that in the last decade, we know that the price of the solar module is very expensive. And also not only the price of solar PV, the component of the solar PV system, such as inverter or maybe converter and so on, is quite expensive. But now, the price of the solar PV module is, if I'm not mistaken, is approaching 6,000 to 8,000 rupiahs per watt peak. So if we would buy 100 watt peak of solar PV module, maybe the price would be 800,000 rupiahs. If we compare it with the 10 years ago, maybe it is quite cheap. So from this point, we can have a chance to develop or to do research in the PV system. And there are several ways to deploying the renewable energy. And as academia, we should to do research to get maybe competitive price in solar PV system, not only solar panel, but also in the components such as inverter and converter and so on. And then the second question, how long would it take to become a renewable product base? How long? Okay, it depends on countries by countries, I think. In Japan, maybe it's quite different because Japan is quite advanced in material, in technology, and in human resources. But in our countries, maybe would be different if we compare it with any advanced countries such as Japan or USA or Germany. But we should have an optimism because the research would be continue to increase in our country. But lastly, but not least, in this case, regarding your question about the time, it is depend on our government. So I think the government should creating or developing a rule that provide us a regulation that competitive if we deploying the renewable energy. So in this case, the responsibility of our government would be play an important role. You know that if we if we doing research by ourselves without any responsibility with our government, it is nothing, because we need any incentive maybe, or maybe we need fit in tariff maybe. So it is depends on the regulation, I think. That is my answer, maybe, Mr. Bani.
Okay, thank you very much.
Answering?
Yes.
Okay.
Okay, thank you very much. And the next question is maybe it's quite similar with the first one, but it is specifically to ask about what do you think about the opportunity of conducting the research in power flow control in grid-connected solar PV? Is there any other opportunities or any other wide opportunities to open to conduct the research?
Okay, regarding research opportunity in power flow control, I think there are a lot of opportunity to do a research in the power flow control. And of course, if we talk opportunities, one of the most difficult thing is how to make our product sell well in the market. So if we have a product and then we do not know how to sell our product, it is nonsense. It is not useful. useful. Yeah. So, in my opinion, beside opportunity subject of the research is how to make our products sell in the market, because it is quite difficult for us as engineering. I think we need other researcher who in the marketing subject. And in general, maybe I think in research subject, we can find the potential research about power flow control in the journal. In the journal, maybe IEEE or maybe Elsevier, especially the journal that discussing about a review paper of the power flow control. And then from the review journal of the power flow control, then we can find the research gap. Okay, and then, however, in general, the opportunity of the research still be focused on how to increase the overall efficiency of the solar PV system. I think this is the main issues that we should consider about to do research in the solar PV system. And then, of course, the overall efficiency will get impact on the cost. So I think the next one is how to do research in getting the decreasing cost of the solar PV system. Okay, I think this is my answer. Maybe I'm sorry if my language is not quite clear enough.
It is okay. The main important part is to communicate it.
Okay.
As long as other people understand, then
Okay.
it's fine. Okay, looks like there are several questions that could not be asked due to the time limitation. However, if allowed by the presenter, all the questions may be asked to the presenter directly through their email address, maybe. And if allowed, then maybe we could share your email address or any other contact number so that other people could contact to the presenter directly if, for their question. And ladies and gentlemen, finally we come to the end of the presentation, and we would like to say thank you again for all the presenters for their informative and interesting talk, and for the audience for your active participation. And hopefully the presentation will be beneficial for everybody. And once again, thank you for your attention and good afternoon. Assalamualaikum warahmatullahi wabarakatuh. And give a big applause for all the presenters. And for the end of the keynote speaker session, I would give the room back to the MC.
Diucapkan terima kasih.
Thank you all for the insightful presentation.
Hadirin sekalian, kita akan melanjutkan acara sesi paralel pada pukul 11 waktu Indonesia Barat. Para pemakalah akan memasuki breakout room yang masing-masing terdiri dari 10 sampai 15 orang. Tiap-tiap pemakalah akan diberikan waktu selama 10 menit untuk presentasi dan 5 menit untuk tanya jawab. Mengingatkan kembali, dimohon para pemakalah untuk mengganti ID Zoom menjadi nama conference, garis bawah, parallel session room atau breakout room, garis bawah nama lengkap. Misalnya SNGBR garis bawah 4 garis bawah Chan Paul Amol. ATASEC garis bawah 2 garis bawah Chan Paul Amol.
For parallel session, each room consists of 10 to 15 presenters. Each presenter has 10 minutes to present their paper and 5 minutes for question and answer session for each presenter. Please change your Zoom ID using the following format: the conference name _ parallel session room _ your full name. For example, SNGBR _4 _ Chan Polomol, or ATASEC _2 _ Chan Polomol.
Bapak Ibu sekalian, presentasi untuk sesi plenari dan paralel akan dibagikan di kolom chat. So we would like to remind you, Bapak Ibu, that the attendance list for the plenary sessions and parallel session will be shared in the chat box. Kindly complete the form. Thank you.
And Saya Chan would like to extend our gratitude for your kind attention and participation. We look forward to seeing you at next year events.
Wassalamualaikum warahmatullahi wabarakatuh.
State Polytechnic of Malang, or Polinema, is a state vocational higher education institution located in Malang City, East Java. Polinema was established in 1982 with the name Education Program of Engineering Diploma, Universitas Brawijaya. Polinema's vision is to be a leading vocational higher education institution in the global competition. Polinema has 7